In the next few examples, we're going to translate and solve linear inequalities. So we're taking the written words and trying to use an algebraic expression to rewrite the words or translate. Specify all the numbers less than 7. So to specify all numbers less than 7, I'm choosing a variable x. Less than is our symbol less than, and the number 7. So if numbers are less than 7, this is how we would write the inequality. That's the algebraic notation. X is less than 7. The graph of x is less than 7 is our number line. Choose a spot, call it 7. Less than is shading to the left, and a parenthesis is used. So the graph is complete. I'm now describing that shaded interval with negative infinity all the way up to 7, but not including, so that's a parenthesis. Set builder notation is the set of x such that x is less than 7. Our next given example, specify all the numbers larger than negative 64 and less than or equal to 89. So the first thing I would do is make sure I write these numbers in order. So we're not just comparing to one number, but two different numbers. So we should start with our smallest number first. So the negative number is smaller than the larger, positive 89. Our variable then will fall in between the smallest and the largest number. If our numbers are less than or equal to 89, that might be the easier side to start with. So numbers that are less or equal to 89. Now let's look at this other portion. It says we're looking for all numbers that are larger than negative 64. So numbers that are larger than negative 64. Well, here's another rule we need to remember. When I reverse the order of the terms, that also tells us to reverse the direction of the inequality symbol. So now the order is matching what I have written over here, and I can clearly see that the less than symbol needs to be used to fill in. So our algebraic notation is in a compound format. Negative 64 is less than x is less or equal to 89. So on our number line graph, we actually will have both of these numbers appearing. The smaller number on the left, the larger number on the right, just like we wrote it for the algebraic notation. So if I have numbers that are smaller than or equal to 89, that would be shading to the left. And remember, numbers that are bigger than negative 64 would be shaded to the right. So you can see the shading converges between these numbers. For greater than negative 64, there's no equal sign, so I need a parenthesis on that side. But notice equal sign is included with 89, so that end has the bracket. The interval of shading then appears between negative 64 and positive 89. Notice the bracket for 89 and parenthesis for negative 64. So the set of x such that negative 64 is less than x is less or equal to 89 is the set builder notation. And our final example here, we have to specify all the numbers larger than negative 14 and less than 0. So larger than negative 14, x is larger than negative 14. We have less than 0, so we're looking for numbers less than 0. Let's put these in order. We've got negative 14 for the smallest value, 0 for the larger value. X appears between. So x is less than 0, we already have that ready to go. But the other symbol, remember, we're going to have to change the order of these terms, and that means the inequality symbol is also reversing. So we're using the less than symbol. Also, your inequality symbols should be facing the same direction. That's another way to know if you're putting things in the right order. So that's the algebraic notation. On the number line, choose two places, the smaller number on the left, larger number on the right. Numbers that are less than 0 shade to the left. Numbers that are greater than -14 would shade to the right of -14. Do you see any equal sign included? Going back to this narrative, do you see equal written anywhere? That means parentheses used on both ends of the shading. So the interval notation will be from -14 to 0, but not including either endpoint. Our set notation for our variable x is the set of x such that -14 is less than x is less than 0.